Hi, so my name is Shawn Pearce. I am one of the 6 maintainers of Gerrit Code Review, and I'm here to talk about how we are ditching our SQL database and using the Git version control system instead. So Gerrit's been around some 6 years. It's a web-based code review system. Eclipse, of course, uses this now, but it started for Android and has grown in popularity in open source communities and commercial companies alike. You can review code on the web, look at a change list. You can open a file and type comments in and suggest people make corrections to their code before it lands in your project. The idea being you can mentor people, you can improve your code quality and reduce bugs before they actually ship. So this is great, but for the past 6 years, we've kept everything in the SQL database. We had a SQL database behind the application server. Comments would be written there. The metadata that you see in the web UI would go into the database. So that worked for us. It's a relatively simple system. A change is a code review. There's a bunch of messages for that change. There's a bunch of patch sets, which are iterations, attempts on making that code change. There's approval scores, things like saying code review +1 or code review +2 or verified that it compiles. Patches used to exist in the database, we dropped it, but conceptually they exist there. Are patches and edit to a single file, and a patch line comment is comments reviewers have written on that. We support a range of SQL databases today. One of the more common ones is H2 because it's embedded right in the application server. You can just install Gerrit and it's self-contained. Originally, we launched with PostgreSQL support because I like Postgres. MySQL came along later. We have, I believe, support for SAP's database and Oracle database today. So we support a wide range of SQL databases. These databases tend to be very small. Even for a very large installation, we're talking only a couple hundred meg. It was more convenience of a structured store than actually needing volumes of data. Since it's such a simple database, we wrote our own database mapper. Hibernate is kind of overkill for our needs. So we wrote a small tool that just does single operations of a Java POJO plain object over to insert statement or an update statement or a delete statement or select to pull that row out of the database. And the way these sort of land in the UI is kind of haphazard. The top right corner of the new UI displays the metadata about the change, who created it, who's reviewing it, what project is it in, what branch will this change get submitted to when you're done reviewing it. Below that, we display the patch set approvals, the current scores, if it's gotten code review +2 or verified -1. To the left, we display information about the current commit, which is the patch set. Below this, we display a table of all of the patches, the files that you've modified in the change. And at the bottom of the screen, we have a history of anything that has happened to this code review. You can, if you pick up a code review 6 months later, you can read the history to see who's interacted on it and what they've said. And each of those history events is a change message. And I, to confuse you, took the file display and threw it into the corner right here and highlighted the patch line comments, which is a comment on a single row, a single line of code. Although in modern Gerrit today, you can also put it over a range of lines or single words or range of words or span of characters. So patch line comment is expanded to more like a range comment, but we still call it patch line comment. This is a very simple data model. There's not a lot of complexity in it. There's not a lot of data really being stored, which is why our database is only a few hundred meg for even the busiest servers that have existed for the 6 years Gerrit's been around. But it's been really kind of awkward. Gerrit Code Review is heavily tied to the Git version control system. You can't use it with Mercurial. You can't use it with Subversion. You can't use it with, I don't know, pick something else, Perforce. But it uses Git, and Git is a distributed version control system. You can share code around between parties at will, but you can't do that with the code review metadata. The metadata is locked up in this one central server, which is kind of the exact opposite of what Git promotes. Git promotes you being able to take your code, put it wherever you want, fork it at will, and move it around between sites, and have things at both at GitHub and at Eclipse, and you can't do that with the Gerrit data. It's also posed a problem for administrators of the Gerrit server. If you want to do a backup because you're a good IT person, you want to make sure you can restore your project's data as necessary after disaster, you need to back up both the Git repositories and the SQL database. And individually, these are well-defined problems. You want to back up a Git repository, you can clone it or snapshot the file system and then dump that off to a backup system. The SQL vendors all have good backup strategies. There's ways to snapshot the database, get a consistent dump from the database, and then you can restore from that. But if the application server is writing to both simultaneously, how do you get a consistent view between the two of them that makes sense between them? And a lot of the data that we use is drawn directly out of Git, which is why we're so dependent on Git. So it's very important that these are consistent as a backup, and today there's no way to do that. So we've been kind of sad for the past 6 years because all of this. So we devised a solution. We actually devised it 5 years ago. Move everything into the Git database. We get instant distribution, just like Git distributes the code. Git would also distribute all of our review metadata, all the comments, all the attributes of the change, and we'd be able to get consistent backups. You can now back up a Git repository at a time, and everything about that repository, all of the code and all of the review information is part of that one consistent backup from that Git repository. So we're done. But it's taken us 5 years to actually work on this solution because it's not really going to work. Git's not a database. So since Git's not a database, we're losing out on a lot of things. There's no structured storage. Like I said, we used a SQL database at the beginning because we needed a simple structured storage system. We've got a bunch of different little string and integer properties that we need to keep track of. And they're all small individually, and it's only a few hundred meg in aggregate, but we don't like reading and writing files and messing with that. There's also no query language and no secondary indexes. A lot of the things in the UI are doing different slices of the data, and having an index in the database makes it easy to say, quickly grab everything that correlates to this file or for this revision of a change. And you can't really do that in Git. There's no secondary indexing system to make those queries efficient. You kind of get stuck with this like, well, we'll search every file in the file system. So by using Git, we've solving our distribution problem, but we didn't really solve why we chose a SQL database to begin with. So to talk about how we kind of reached the point that we can do this, it's interesting to look at what happens with the change search functionality in Gerrit. In our UI, in the very top corner here, there's this search box, and you can type in a very complicated search expression to identify changes that match what you are looking for. You can find those code reviews and then you can review them or re-review them, whatever. We have a bunch of different properties, things like you can ask certain status, is the change still open for review, or has it been merged to the project, or was it abandoned? Who authored the change to begin with, by email address or their name? What project is it in? When you have something like Android that has 600 repositories, or Eclipse that has maybe 1,000 repositories, you might want to be able to narrow your project search to areas of the overall system that you currently care about. You can specify which branch. Are you interested in a release branch, or something in the master branch, or something in an experimental branch? You can do full text search over messages, over the commit message, and search for things like, did you fix a bug, and see if they put fixed bug in it. You can search over how many lines they modified, more than 50 lines, less than 5. Ranges or exact match, exactly 50 lines changed. All of this was very hard to do with our naive database system that we used with SQL. The naive mapper we wrote required all of our where clauses to be precompiled into the app. The nice thing is there's no SQL injection attacks possible. If everything's statically compiled into the app, you know what's going to the database. Everything was bound by bind parameters in the prepared statement clauses, so we didn't have to worry about like escaping or things like this. We don't have to worry about constructing large, nasty where clauses. We don't have to worry about driving the database server into a table scan because somebody fed in a bunch of things that weren't indexed as a where clause. But we had to create a lot of different variations of these where clauses to try to satisfy these search criteria that the user could type in the search box. And the mapper wouldn't allow us to do cross-table joins because when it gets the select list back, each column goes to one property of one object in Java, end of story. So we couldn't build a join of a couple different tables to search different properties simultaneously. And only some of the data is actually in the database, which is why the database is only like 100 meg or 200 meg. A lot of the data is actually in Git. The commit messages are in Git. The files that are modified are in Git. The how many lines did you modify is in Git. None of that is in the SQL database. So we had to do a lot of joins and filters kind of inside the application code and reinvent the wheel. And we actually have I think we haven't deleted it yet. It should die. We have a thing that does a query optimizer in Java that looks at what clauses you're using in the query, tries to guess what the cardinality results for each different clause will be against the database, and then prioritizes them to find the one that will have the fewest number of results, and then runs that first, and then filters the rest in Java, and will sometimes run another join and then do a hash merge in memory in Java. We re-implemented a SQL database because we had this naive SQL mapper. It didn't scale. So, and we couldn't do things we wanted to do. Things like the delta operation were actually so horrifically expensive at the time that we didn't even support it as a feature in the search language. So we knew we had to improve change search, whether or not we did anything with the SQL database. And we rewrote the change search system on top of Apache Lucene. And we also support Solr as a clustered version of this. You can connect it to either Solr or Apache Lucene. We run the inverted index next to the SQL database. Each change code review is one document in that system, and all of our searchable properties get converted into terms that are fed into the index. And we convert your query, instead of building this SQL-like optimizer in Java, we just convert your query into a predicate tree for Lucene or for Solr, and we send it off to the index to be searched. So a translation of the query saying, is the change open, is really searching for the status field having any of the three open states, new, submitted, or draft. The owner gets resolved from the email address to the internal identifier we use for the accounts, in this case 5001. The branch operator is really written in terms of the ref operator, prefixing it with ref's heads. It's syntactic sugar for you. The message operator is a full-text search. Lucene is a full-text search product. It's capable of doing that. The delta operator is searching for a range between 50 and max int. That's how we can specify greater than. So we run the index search in Lucene. We get our documents, our changes matched from the Lucene. We rank them and sort them to try and find things that are new and newer is always sorted earlier than older. And this works well for the search. It is now actually pretty fast. We don't have to do these nasty merges in Java. All the database, all the responsibilities thrown off to Lucene or Solr. But Lucene updates can be slower than doing a SQL update. So we do them async. And we have an optional method. I'll actually show you this a little bit later in the code. We have an optional method where we can wait for the index update to complete, allowing us to guarantee that if we search immediately after that update is finished, that we would find the results. When we start the update, we don't yet guarantee that a query would show that results document yet. It may still show the old results. So if a property changes, we may not reflect the update yet. So once we had this in place, and we did this before we started the SQL to Git migration, it resolved two of the big feature gaps for Git. The query language secondary index sort of thing is gone. All of our important data that we want to search over has been copied into Lucene. So Lucene is responsible for that and can be rebuilt at any time via this reindex program. If you lose your Lucene index or it becomes corrupt, you can ask it to rebuild off of the base SQL database or off of the Git data. And we spent a lot of time optimizing this reindex build. One of our larger Gerrit servers at a company that I won't name, but it's not mine, the original version of the reindex needed like 3 days to run for their like 6 years of history, and they're a very prolific development company. They produce a lot of changes. We optimized it down to like an hour and a half. So they can rebuild 6 years of the development history in an hour and a half on a reasonable sized server that they're running Gerrit on anyway. The reindexing process is also capable of being done online. The Gerrit server can do it itself in the background while it's doing execution for users, and you can also run it offline and then copy the index in and bring it up the server next to it. So you can run on a separate machine if you had to do a reindex. But because we can completely rebuild it, it gives us more freedom to start innovating with the data model itself. We can make changes to the data model, and the index will still be there. But we didn't really resolve that structured storage concept about Git. We have structured data. We care about tracking a lot of little strings and integers, and there isn't a place really to do that in Git. Git is a version control system for source code. So there is some structure in Git, and we try to take advantage a little bit of it. Today, you have a Git repository with like a branch, refs, heads, master in it. Gerrit Code Review is going to create snapshot refs, refs changes 85.3, 85.1, 85.3, 85.2 as you iterate your code review. We're adding an additional ref called meta that tracks the data about that code review. The 385 is our primary key. We've always assigned this number to a change when a change gets created in the server, and that's what you see in the URL. That's when you get an email from Gerrit. That's what it sends you in the email to open it up. So since the primary key is in the ref name, we can always find it efficiently, and it's unique. The ref Git won't let you create another ref with that exact same name. We shard them mod 100 just to spread load in the file system, as Git puts these refs in directories in the file system. The 1, 2, blah, blah, blah suffixes are different revisions. If you create a change, that's /1. You modify it to address comments from your reviewer, that's 2. You keep doing it, that's 3. If you are having code reviewed by me, you'll get to 70. I'm very picky. But this has always existed. These are commits built on top of your source code history. It's connected to your source code graph. Some of them will be abandoned, and some will get merged into your source code history as permanent part of your repository. These have been around since Gerrit 1.0. It's one of the one of the innovative features we put in Gerrit 1. And GitHub today does something similar with pull requests in the refs polls namespace. Not quite the same thing, but it's a very similar idea. The meta branch is new. It is completely unrelated to your history of your project. I'll show you the history in a second, but it was newly added for the SQL Git migration. You might only see 4 or 5 commits in the meta branch, and it has no correlation to your source code. It's nice that Git allows you to do this. So the history at the bottom of the screen shows you everything that has ever happened to this change, which, if you think about it, in a version control system, that's what you want for the version control system, is to show you everything that's ever happened to your source code. So we're using the Git commit graph and the history of that meta branch to tell us the history of the change. Every event that happened in the change is written as a commit. The author of that is who we'd attribute the message to. The timestamp is what the timestamp is. The comment that you see in the web UI is part of the commit message that you see in Git. So the Git graph is a perfect fit for that change message entity that we need to store from our database. And much of the metadata that is in there is who wrote it, what time did they write it, and what was the message they wrote, which is exactly what a commit object is. So if you look at one of these exact commits, the body of the message and the attribution is the change message entity that we care about. And we stuck in the bottom of it the patch set approvals as a label. And this standard of putting stuff at the bottom of your commit message has been semi-formalized in the Linux kernel community for many, many years. They put signed off by and their name, or act by, or attested by in their name. And Eclipse, of course, does this with contributor agreements. You can put signed off by in your commits if you don't have a contributor, if you're not a committer on the project, and use that to sign your CLA. So we've just extended that with this label with the actual votes. The code review -1, I didn't like it, you should fix this. Or code review +2 looks good to me. This can be repeated as a field, allowing us to also say label verified. I didn't put that in an example, I probably should have. The standard of adding these footers at the bottom, Gerrit further perpetuated by having change ID, right? If you make a code review in Gerrit, you put change ID at the bottom of your commit message and that gets uploaded. And it's starting to be more formalized in the Git core community, where they're creating tools to manipulate these bottom footers by machine and get a more regular standard for what these look like. So putting bits of metadata down there is becoming a more common concept and has good tools for it. The patch line comments, when I write comments about the code, get put into the tree as files. And I'll show that in a second. So in the web UI, for a change that had like 2 versions, you upload the original version, patch set 1 at 10:40 in the morning, and the reviewer didn't like it, so you upload patch sets 2 5 minutes later. Woohoo, fast turnaround. These have commits, and they're known to get in that refs changes like /1 and /2 namespace. We store comments keyed by the commit that the comment was written about. And we store them in the meta tree using files that are just names that commit SHA-1. So we have a file named 3090 because that's the name of the commit, or 9C8 because that's the name of the commit. This is actually a standardized format in the Git community called Git notes. Git notes are annotations attached to a commit after the fact. And you can put them in branches in refs notes blah, and you can fetch and download refs notes blah after the fact, and you can run git log -- notes equals blah, and I'll show you the commit, and then any annotation that was added after the fact. So by using this, you can pull out the comments and view the comments via git log. But you wouldn't normally look at these in a log because not all of these commits will land in your permanent history. Only one will really land in your permanent history. But this is a scalable tree. Up to like 128 or something commits will be listed in a single directory, and then it starts fanning out automatically as you have more commits. So if you have a lot of comments in a code review for a lot of commits, because I'm your reviewer, it will fan out and scale nicely within the Git system itself. So within one of these files, if we look at the 3090 comment file, they're just blocks of text that say who is the author, who wrote that comment, what time they wrote the comment at, and then the text that they put at a line 1, line 5, and these can be concatenated. So it's a very simple model to merge these files together. If you get changes from 2 different people editing the meta branch at the same time, you merge them by just concatenating them, because that's all the web UI does anyway. The records were inserted as separate records in the database, and they were concatenated when they get displayed in the web interface. So we just concatenate them in here in a relatively simple text format, and we can pull them back out and use them. So getting the projects there, we have the SQL database, and we use it for everything. All of our data is stored in it, and the project is heavily depended upon by a lot of teams. We're slowly adding this migration path. We started, this code snippet's taking out of the piece of the server where you are publishing your comments and sharing them with other people, and you're putting your score in. So the database updates are this block here about inserting your comments into the database so they can be viewed by somebody else, updating the labels, those patch set approvals. We've been schizophrenic about the name of those. Label, patch set approval, not sure. Inserting your message, the change message record. And then if there was any database updates out of those, then we also update the change itself, bumping its timestamp so that it percolates up in history. We added the Lucene indexer first, and we do that as an async operation. It gives us back a future, and the indexer, now that all the data is in the database, just sucks it out of the database and writes out the Lucene documents. But Lucene is not an instantaneous operation. We do that in the background. There's a background thread that will read up all the data from the database that was written above, build up the document for Lucene, submit it to Lucene, but Lucene needs time to digest that and get it into the index and make it actually readable by a reader. So we don't promise the read right away during index async, but that gives us time to then format the email that we're going to send out to let you know that these comments have been made. And while we're formatting the email, once we get the email formatted, we hand that off for async delivery via SEMTI, and then we wait for the Lucene update to complete. And when we start waiting for that to complete, we force Lucene to make sure it picks up that new version of the index that has the updated document in it. And when this indexed write checked get is done, we know that we can tell the caller your update is done, because if you search for that, you would now find it. The index has that result. And that batch reindexer is the same code as the indexer right here. It just is running it highly parallel in a optimal ordering over all changes in the database. So we use that same code for online and offline reindex building to either refresh the index on incremental updates or for a full rebuild. So we got that in place for the change search, and that was working well. And then we started going back in and start doing Git updates. And the Git meta branch is now written in parallel with the database updates. So we love Juice. Everything is a factory builder prototype thing in Gerrit. So we create an update factory that knows how to write to Git. And then that update, we pass it through the database routines so that the individual database operation functions update the database and attach the data to the meta branch update. And then we commit the meta branch update. And then we run the indexer. And now we're writing the data in parallel to two places. We can write it to the database and we can write it to Git. And the indexer is currently reading only from the database. But there's a flag we can flip in the code that says the indexer should read from Git instead. And once the migration is complete, we just flip the flag and we can start reading from the Git repository. The metadata update, that update.commit function is just a wrapper around the boilerplate that you've got to do to make a commit in JGit. You open up a ref update on the meta branch. You set up the tree to be the same file contents that was there before. The parent commit to be the current tip of that tree. Provide an attribution, provide the message of what you want that commit to be. And then JGit is serializable, right? Git is serializable itself. You can say that the update should only take place if it's exactly what you read. And if it's not, then you can go back and retry the entire operation and reread the current state and reevaluate how you're going to apply your update in light of that current state. So we can set that the update should only go through if it's exactly what we started from. And then we insert our new commit and we write the update out. The nice thing about this, I didn't show all of this code because it's kind of obtuse the way it's put together in Gerrit, just because it's obtuse in Gerrit, not because it's obtuse in JGit. But there's a new type in JGit called batch ref update, where we can combine multiple refs into a single operation. So if we merge a change, we can update the meta branch and master simultaneously. We haven't finished all the code for that in JGit. The type is there, and in certain implementations of JGit, that's an atomic operation. They both succeed or they both fail, which means you never get into the state of the change says it's merged, but it's not in the branch. Or it's in the branch, but the change is still open. We still have code to finish to, in the standard version of JGit, make that fully atomic. Git core is working on making that fully atomic, so you can run git push with two branches simultaneously, and that'll be either both succeed or both fail. Today, one can succeed, one can fail. Git core now has a locking policy of how that works. JGit now needs to implement the same policy, and then that will be atomic. So kind of the advantages of doing this is we now have federation possible. We can share code review information as easily as we share the source code itself. We can ship that code review information between different Gerrit servers. Development teams within companies that are collaborating on a partnership. This happens all the time in the Android ecosystem. Chipset manufacturers working with a handset manufacturer that they supply chips to, and is working with like the Google team at the Android team at Google. They want to share code, but each of them is looking at their internal company Gerrit server. They don't want to go look at some shared Gerrit server someplace. People forget to go look at that dashboard. If the Gerrit servers themselves are federating between each other, then the review information is pulled into your company server's dashboard, and you can just look at the dashboard. And you don't have to worry about firewall rules about who can contact what server if the server allows it to make the contact out, the server-to-server contact, and if you put workflow rules into your Gerrit server of this can be shared out after we've gotten these approvals or these reviews to make sure that it's shareable, then the Gerrit server can make that connection on behalf of the engineers. So it'll really support collaboration between Gerrit servers. We're really hoping that this takes off as a metadata format, that it's simple enough that we can also see somebody like GitHub export their pull request in a similar format, or be able to consume Gerrit metadata in their pull request web UI in a similar format, allowing for better interop between groups that like to use Gerrit and developers like to fork and submit pull requests on GitHub, which happens with Eclipse projects. We're really hoping to make offline code review more feasible. I know you can do this to some extent with some tools, but it'd be a lot more convenient if you can fetch all the code review data at the same time that you're fetching the master branch of your project right before you jump on the plane. And then instead of paying the €39.95 that they want to charge you for in-flight Wi-Fi, I can't believe the prices they charge. You can review offline, update your meta branches, and when you get reconnected to a cheaper internet connection, you can push everything back to the server and it will be published and available for others to look at. I'm hoping that since it's a simple enough text format, that you can manipulate using the Git command line tools, that some guy is going to write like an Emacs plugin for this and make Emacs users really happy. I'm a VI person, so I don't care, and it won't be me, but that's my dream, is that there'll be tools built for interfaces that people like to use that will be relatively easy for them to do using command line tooling and get that in place.
Regarding this, at the beginning where the Gerrit server was available, we had like some client that were interacting with it, but each time there was a new version of Gerrit, like, you know, the thing would break. With this new approach, are we going to have a bit more backward compatibility?
Yeah, exactly. So with this approach, one of the things that we're so concerned about and they're conservative about is once this format is actually rolled out, this format's set in stone. Because even if we start making evolution, you're going to have changes from 3 years back or whatever in your server that are in this format, and you're not going to go rewrite those histories of those meta branches in order to get there. One of the things that we did even earlier was, what, Gerrit 2.4 or 2.5, I can't remember what version, we moved all of the access control information out of the database and stuck it into the Git repository. And that format pretty much was set in stone the time that that happened and has stayed with us for several years. So we're trying very carefully to get this exactly the way we want it the first time, to make that less likely to happen. The other thing is the server today has a new, we call it a REST API. It's REST-ish. I wouldn't say it's perfectly REST, but that API is stable. Once something is in a released version in that API, we kind of think it's set in stone, and we don't want to go back and make changes to it. This Git stuff is probably going to land in Gerrit 3.0. We're probably only going to call it 3.0 only because we're already nearing 2.10 in our numbering scheme, and this is a kind of a big departure of jumping from a SQL system to a Git system, but the REST API won't change in 3.0, and this format probably, once it's in place, won't change. We're really trying to get a standard. So I'm hoping that that will make it easier between the REST API, where you can talk to a Gerrit server, and this format where the tools can just write this format directly, and where the command line is like understanding these footers. Between understanding these footers and the Git notes format, the command line has a lot of tooling already available to kind of process these meta branches without a lot of you having to write your own like formatting and parsing code, and that will make it really easy to like write scripts to interact with Gerrit and just do it at a Git level without even worrying about a REST API and JSON and all of that crap. Does that make sense? So we realized we missed a lot of opportunity early on with having an unstable interface and things like that, and we're trying to learn from that. And this will also allow atomic transactions, like I said, updating both the meta and master branch at the same time, so it's all or nothing. You don't get a half state that is confusing. You've got to get your admin to help you get it out of, and allows the admins to have a consistent backup state. You can move a project between servers now. You can trivially just clone the Git repository and then reindex, and you have it built. So that'll be really nice sort of functionality. And that's it. And we've got like 5 minutes for questions or something.
We had a workshop yesterday regarding modeling, and people wanted to be able to do model review. I mean, there's lots of modeling projects at Eclipse, and but to be able to do review on models, we need to add different information. Like it's not just source code and line numbers. So it will be a bit different what we have to store in Gerrit. Will this help somehow store additional type of info or support different type of?
Probably. We have a lot of space in the sense that it's a file system. We can start storing a lot of things in it, but when you start storing structured data, it becomes problematic. I don't necessarily have a solution off the top of my head for storing more structured data in here. I know people want to feed build information into Gerrit. Right now, we're under the idea that build information should be reported into the web UI by a plugin and is not something that's fed into Gerrit directly. Or if it's fed in much like a human is, as it's just a comments with data in the comments that is like a hyperlink. But if it's really structured, you probably want your own UI to render it, in which case you should be responsible for storing it and correlating it yourself. Which then means maybe we give you directory names inside of that meta tree or something that you can store your own data into, and then it becomes a problem of you defining what that format looks like and making it sure that that's stable, and then we just make it easy to surface that into the plugin for the web UI. So that's probably the direction we're going to go, but we haven't made concrete plans there yet. There's one more in the back.
Is there a migration tool to migrate them from SQL to the indicator?
Yes, there is a migration tool. I didn't show the name of it, but there's a migration tool that will grab everything out of the database right to the Git repositories, and then it might also optionally allow you to run the reindex at the same time. I don't remember if it's wired to that, but the way the code's built internally, it will probably have that option so that you can just say, if I'm coming from like a Gerrit 2.4 server, which has neither of these features, and you're going to like 3.0, it'll just do everything in one shot, and it'll probably be a couple hours of downtime to do that. But a lot of this we're trying to do as an online reindexing option so that you could run that on another machine for a couple hours, copy the indexes over, restart the Gerrit server with the new 2.10, and then allow the online indexer to catch up the delta between where you had done the shutdown point is. We're very mindful of trying to minimize that sort of downtime for the upgrade.
Is there any rough timeline?
We had hoped to have this done by the end of this year, but that's looking more likely to slip towards like February. All right, I think I'm out of time, so thank you guys. I think I'm way over, but thank you.